Hello, and welcome to Getting Started with AWS Shield Advanced. My name is Ian Olson, and I'm a Senior Technical Account Manager with AWS. Today on our agenda, we're going to walk through subscribing to Shield Advanced and what things you need to configure as part of that. Specifically, we're going to talk about protected resources and additional considerations regarding the act of protecting a resource. We'll review the new events and monitoring capabilities that are provided to you by the Shield Advanced service. Some next steps focusing on additional AWS services that help supplement Shield Advanced directly, and finally, a few resources to help you along the way. To start, let's subscribe to Shield Advanced and walk through what it takes to do that. So from the WAF and Shield service under AWS Shield Overview, go ahead and subscribe to Shield Advanced. Before you can subscribe, you have to confirm the following 4 statements. Let's review precisely what these mean, as we do get some questions on several of these. First, the pricing. The $3,000 per month subscription fee. This covers any account within your organization. To be clear, this means it is not a per account fee. It is actually not even a per payer fee. If you are an enterprise customer or a larger customer and have multiple payers, that flat fee covers your organization, and that includes multiple payers. Please note, if you do have multiple payers, you need to reach out to your account team or support through a support case, as we will need to configure some custom billing to support that. Also for pricing, for any protected resource, there is an additional data transfer out fee, which varies based on the type of resource and the tier of usage per month. Commitment. There is a 12-month commitment to the Shield Advanced service upon subscribing. And by default, the service does auto-renew within 12 months. However, at any point via the console, via a support case or API, you can disable auto-renewal, at which point the service will not renew and no longer bill. Once you've done that, you can subscribe, and you are done. Real fast, this is not a regional setting, so the Shield service itself is global. You do not need to do this per region if you operate in multiple regions. You do have to configure this on each account, however. Next, let's go ahead and protect a resource. You can either do it directly from the overview page here or the protected resources tab on the left. When you go to protect through the console, you're prompted to select either what region or what resource types you'd like to load. You can filter this down to look for specific resources if you'd like. For our demo today, we're going to look at the global region, which is CloudFront, Route 53, and Global Accelerator, and we're going to just do CloudFront. I'm selecting only one CloudFront since I only have one. However, if you have multiple resources of the same type, you can select multiple and bulk configure them in in a single step. The first thing you'll be prompted to do through the console is to configure or associate an existing WAF WebACL to your resource. While I already have one, we're going to create one through the console just to walk through what that looks like. You're going to give it a name, and this is going to create the WebACL for you in the region in question. So this is CloudFront, it'll be in the global region. You'll see that WebACL, you can associate to new resources, etc. You're also prompted to add one in particular rule that is a critical best practice for just DDoS protection, and that is a rate-based rule. This rule is global, meaning it's going to not care about URI or anything else, just in general. As configured in the screenshot here, I have a rate limit of 1,000 and an action of block. What this means is that if any single IP address exceeds a 1,000 rate limit within any rolling 5-minute period of time, WAF will block any requests above that rate of 1,000 until the rolling 5-minute window comes below 1,000 again. Quick confirmation. The next step is to configure, this is optional, but a health check associated to your Shield protection resource. This configuration is required if you want to do proactive engagement. We will be discussing exactly how that works later. For the case here, I already have a health check. We'll look at those in a second, and I'm going to choose to associate one to my resource. Let's talk about Route 53 health checks. The health check you see here is a HTTPS probe to my CloudFront site, and it's expecting a 200 response back. It's checking from the 3 default regions from the Route 53 service for health checks. However, there are many regions to choose from. There are a lot of custom settings you can do here. You can change the expected response, add a search string, etc. The default check like this is fine, however, you should definitely ensure whatever you're checking in case of CloudFront is not a cached thing, that it accurately checks the health of your actual site. There are a total of 3 different types of health checks. In addition to this HTTPS probe, you can also build health checks that correspond to a CloudWatch alarm, and the health check will match its state to the alarm's status. For example, with CloudFront, some best practice default metrics you may want to consider are origin latency, 4xx and 5xx rate on the CloudFront distribution. You would create a health check per each alarm, and that would associate here, and they would mirror states. The final type of health check is called a calculated health check. A calculated health check lists a number of other health checks and states a minimum number of those health checks that need to be healthy. For example, in our CloudFront demo here, if we had this probe and the 3 other default best practice health checks that we stated, we would have a calculated health check, for example, that said as long as 3 out of those 4 are healthy, we'll consider the resource healthy. I'm associating a probe for my demo here. However, in reality, it is typically going to be best to have a calculated health check that you associate the Shield Advance, which checks several things to ensure application health. Next, through our console experience, we're prompted to establish a number of alarms and SNS notifications for those. The first alarm is if DDoS event is detected per Shield Advance. We'll take a look at this later, however, there is an additional namespace now available in CloudWatch metrics that describes if a DDoS attack is detected or not. If that metric triggers, it will send an SNS notify, and this is basically establishing that CloudWatch alarm for us. The next section is establishing if we should have a CloudWatch alarm if any rate-based rule is exceeded. And again, if we exceed it, we will send an SNS notification. Finally, we are given a quick chance to review our config and say finish, and we've protected our resource. After you protect it through the console, you'll be brought to this page in which you'll see any protected resource on this account. Again, Shield Advance is global, so this will show both CloudFront and any regional resources you already have protected. At this point, you can say add more resources to add more, or select one you already have and change the configuration of the resource. So let's go back now and finish configuring Shield Advance. Our next step is to configure and enable AWS SRT support access. As part of doing this, you will establish or use an existing service-linked role that will authorize the Shield Response team to make updates to WAF Web ACLs on your account. I already have one, so I'll select it. So let's talk about exactly what this allows SRT to do and when this is done. First off, while this role exists, it allows our service principal for this team to make WAF WebACL updates on your account. This is only done while working with you. This is not something that we are proactively or otherwise doing on your behalf. The reason you would want to have this is if you are in a DDoS event and there is the need to make or add a WAF WebACL rule, adjustment, anything like that. If you are not comfortable doing it, if you don't do it very often, this team does this day in, day out. They can help you ensure that we respond and make these adjustments quickly without causing any impact. You do not need to do this. The WAF WebACL updates they're making are things you can absolutely do yourself through the console. It's nothing special. It's simply a predefined mechanism for us to have that access. Once we have that, the last item is to finish configuring the proactive engagement and contact section. The first thing you'll need to do is add one or more contacts, ideally several. Per contact, you'll add an email address and a phone number and an optional note if you'd like. So let's add a contact 1 and our phone number, and I'm going to add a second contact for my SOC. So a common question we get here is, who should be here? There is no one-size-fits-all answer. However, this should likely be anyone that if an event is occurring on a resources account, that is going to be able to work with us as an SRT to work with you to make adjustments as needed or otherwise review the nature of the attack. Common examples of appropriate use cases are a SOC, your security team, application teams, or a product team. Another call out that we recommend, it's not required however, is if you're going to list contacts and these are named individuals, that you definitely make sure you have several people listed, as we will reach out to them until we get a hold of someone. For example, a distribution list for a SOC is great. If you have contacts, that's fine, but again, we recommend that you have multiple contacts available. Once we have context, we'll be able to actually say edit and enable the service, and proactive engagement is now configured. When you turn it on, there may be a notice that SRT is reviewing your setup. That will go away within a couple hours after a review is done based on the context provided. So now we've finished proactive engagement. Let's finish talking about exactly what that feature does. So we already talked about the Route 53 health checks, when those are associated with a protected resource. When that health check is failing, and at the same time, Shield Advance determines based on its insights that it is seeing what looks like a DDoS attack event against a resource, both of those together will trigger proactive engagement, where AWS SRT will begin reaching out to the contacts you specified below in order to get a hold of someone. Another question we get, and just to be clear, proactive engagement does not in any way impact your ability to reach out to us at any time. Regardless of proactive engagement being enabled, configured, or not, you can always reach out via a support case through the Shield Advance service that you were under a DDoS attack, and that will connect you with the SRT response team, where we can either help triage or review with you and make any adjustments, or help you understand what should be done. Let's start looking at the various events and monitoring. The first thing is directly from the Shield console under the events page. On the page here, I've done a simulated attack just to demonstrate in the console. However, if you received a real attack, you would see the resource in question, its current mitigation status, the attack vector, things like that. Once the event has been mitigated and completed, it will switch over to mitigated. Along the way, you'll be able to open that event itself and get more details regarding what's occurring. So again, I get the distribution in question, the attack vector, start and end time is applicable, if there's automatic mitigations, more details on what type of mitigations. My screen does not show it here. However, you will get additional resources such as how many bits were detected, for example, beforehand, and mitigation metrics for supported resources. The other part is going to be additional CloudWatch metrics that we discussed. So as we said, there is now a new namespace available for AWS DDoS protection, and under there we have 3 categories of metrics. The first category is our attack vectors. Per resource that you protect, you will get these 21, or if it grows, more metrics for each attack vector, and the number of either bits or requests is appropriate that we have detected, and we meaning Shield Advance. This data point will present either the bits or produce a 0 or more frequently a null data point when there is no attack detected. If you are using CloudWatch alarms or other mechanisms, ensure that a null data or lack of data is a non-breaching action. The next one, which one of our alarms use, which we'll look at in a bit, is a DDoS attack detected. This is a simple 0 or no data, or a 1 that there is an attack in progress. What you will typically see is that this data point will go to a 1 when Shield Advance detects an attack, and it will emit a 0 when the attack is determined to be either mitigated or concluded, and will otherwise not produce metrics. So again, ensure alarms and such have not breaching for no data points. Finally, we'll also emit metrics regarding the amount of packets that we are dropping or passing, depending on the attack vector, exactly how that works, things of that nature. That data is also available presented as a CloudWatch metric per resource. So quickly, we talked about the alarm. This is the alarm that the Shield Advance console set up for us. It's a standard alarm. You can always make them yourself, but as we can see, it's consuming that new namespace DDoS protection, DDoS detected metric. It's looking for a value of 1 or greater for any one minute period, and missing data is treated as good. And we configured an action, so our actions will show an SNS topic being published to. So, we've set up Shield Advance on a single account. We protected a resource, we put a basic WAF in place. What are some next steps to consider? There's 3 services in particular that really expand the Shield Advance and just DDoS protection and mechanisms available. The first is Firewall Manager. We're going to walk through these, but Firewall Manager, AWS WAF, and Security Hub. So let's look at how these relate to Shield Advance directly. First things first, for Firewall Manager, there are 2 security policies that are very relevant. The first is our Shield Advance type, which allows you to do organization-integrated auto-protecting of resources. So while we went to the console here and said protect a resource, selected it, and did things like that, this policy allows you to scope to either OU, accounts, resource types, and also allows you to scope in and out based on tags of destination resources and automatically enable shield protection. You can also do this for WAF web ACLs. It's a little more involved, so I don't have an example on my page here, but you can also use it to create and associate and automate much of creation and just actions regarding WAF. For WAF itself, we added a single rate-based rule. However, WAF can do considerably more than just that basic rule. As an example, I have a rate limit rule like we had before. Amazon provides a series of managed rules for things such as bot control, a list of known poor IP reputations, common rule sets to protect against OS top 10 things. You can also make a huge number of custom rule groups based on your application or company requirements. And finally, Security Hub. The monitoring abilities we saw definitely work, and you can always use those. However, if you choose to use Firewall Manager to do your WAF web ACLs and to do your shield protection, there's a really great integration in which Firewall Manager will send all of these alerts across all your accounts centrally to Security Hub. For example, like we saw before, I had a simulated DDoS event on my one account. However, in my Security Hub account, that information is also pumped up here centrally, so my security team, without checking every individual account, is able to see this from a central pane of glass, set up notifications for themselves, all the great stuff, the benefits of Security Hub, like that. Beyond that, there's some other best practices and resources that you should be aware of. First off, there is a white paper we've published regarding DDoS resiliency and best practices. This is going to cover proper architectures, AWS services, and just general technology concepts to ensure that you are building applications in such a way that they can be properly protected from DDoS from a resiliency perspective. Shield Advance and WAF are great. However, as always, architecture is important to ensure it meets your requirements. I've talked a lot about WAF rate-based rules. So I've included an additional security blog here, which talks about 3 of the most WAF rate-based rules that we consider, what they are more specifically, and how to identify how to configure those. Thank you.